This is the North Atlantic Crossing, a stretch of ocean so vast, so violent, that even the machines orbiting Earth struggle to understand it. Here, storms are born faster than warnings can be sent. Waves rise higher than buildings. Cold erases strength in minutes. Navigation fails. Communication fractures. No shelter. No rescue nearby. For centuries, ships vanished without a signal. Today, even satellites, our most advanced eyes in the sky, lose data, lose accuracy, and lose certainty over these waters. This is where technology hesitates, where nature still controls the rules, and where crossing mistakes are paid for in lives. The North Atlantic Ocean is not just a body of water. It is a moving system of violence, pressure, cold, and chaos. Stretching between North America and Europe, this crossing has been one of humanity's most essential and most dangerous routes. Trade, migration, warfare, exploration, and modern aviation all depend on it. Every day, hundreds of ships and aircraft attempt to cross it. Most succeed, some do not. What makes the North Atlantic unique is not its size, but its behavior. Unlike calmer ocean basins, this region sits at the collision point of multiple atmospheric and oceanic systems. Warm tropical currents meet polar cold. Storms born off continents mature here. Winds accelerate without obstruction. For centuries, sailors believed this ocean had moods. Today, science confirms it does, measured in pressure gradients, thermal contrasts, and wave energy densities that surpass nearly every other ocean crossing on Earth. This is the ocean that does not forgive timing mistakes. The North Atlantic is bordered by powerful land masses. To the west, North America feeds cold air masses southward. To the east, Europe funnels weather systems east to west. To the north, Arctic ice injects frigid water and drifting hazards. To the south, tropical heat pushes energy northward. This geography creates compression. The ocean narrows at higher latitudes, forcing winds and waves into tighter corridors. This compression amplifies storm intensity. Waves stack, systems overlap. Conditions change within hours. Depth adds another threat. The North Atlantic contains deep basins exceeding 5,000 meters. When storms pass over deep water, they draw more energy. Waves become taller, faster, and more unpredictable. Rogue waves, walls of water exceeding twice surrounding wave height, are statistically more common here than in most oceans. And then there is cold. In winter, surface temperatures hover just above freezing. A human immersed without protection loses muscle function in minutes. Survival time drops below 15 minutes in many areas. Rescue windows are brutally short. Ocean currents. The North Atlantic is dominated by the thermohaline circulation, often described as the ocean's conveyor belt. Warm water flows northward from the tropics, releasing heat into the atmosphere. Cold, dense water sinks and returns southward at depth. This exchange fuels storms. Warm water energizes cyclones. Cold water destabilizes them. The boundary zones become breeding grounds for violent weather. Unlike tropical hurricanes, these storms grow through temperature contrast, making them harder to predict and faster to intensify. Atmospheric instability. Jet streams pass directly over the North Atlantic. These high-altitude winds steer storms and inject rotational energy. When jet streams dip southward, they collide with warm ocean air, creating explosive cyclogenesis. Storms that deepen pressure faster than forecast models expect. Meteorologists call these weather bombs. Pressure drops so rapidly that winds exceed hurricane force without official hurricane classification. Ships encounter conditions they were never warned about. Seasonal extremes. Winter brings darkness, ice, and wave heights exceeding 20 meters. Summer offers no safety. Fog reduces visibility to zero, while sudden squalls emerge without warning. The ocean never rests. Long before satellites, sailors feared this crossing. Viking ships, medieval traders, and colonial fleets all documented brutal storms and unexplained disappearances. Navigation relied on stars that vanished behind cloud cover. Compasses malfunctioned during magnetic disturbances. Entire fleets vanished between ports, leaving only wreckage or nothing at all. Atlantic, it entered iceberg fields created by unusual current shifts and seasonal ice drift. Warnings were received, but speed was maintained. The ocean was calm, visibility was clear, and that was the danger. When the iceberg struck, cold Atlantic water flooded the hull faster than pumps could manage. Lifeboats were insufficient. Hypothermia killed more than drowning. The North Atlantic did not need a storm. It used temperature. Over 1,500 lives were lost. The perfect storm, 1991. In October 1991, three weather systems collided over the North Atlantic. A cold front, a low-pressure system, and the remnants of a hurricane merged into one. The storm exceeded forecast models. The fishing vessel Andrea Gale was last heard heading into it. No distress call followed. Waves were estimated at over 30 meters. Winds exceeded hurricane force. Debris was found. The crew was never recovered. The North Atlantic had created something science could barely measure. Air France Flight 447, 2009. At cruising altitude over the North Atlantic, a modern aircraft lost accurate airspeed readings due to ice crystal interference. Automation disengaged. Pilots were forced into manual control in darkness and turbulence. Satellite communication recorded fragments. Weather radar showed towering storm cells. In less than 4 minutes, the aircraft stalled and fell into the ocean. All 228 people on board were lost. Technology failed, not because it was primitive, but because the environment exceeded its assumptions. Satellites rely on predictability. They measure cloud tops, wave heights, wind vectors, and temperature gradients. But the North Atlantic produces interference zones, areas where data becomes unreliable. Dense cloud cover blocks optical sensors. Rapid storm formation outpaces update cycles. Sea spray and ice distort radar returns. Magnetic anomalies interfere with navigation signals. Satellites do not fear, but their error margins widen here more than almost anywhere else on Earth. Warnings become estimates. Certainty becomes probability. And probability is not enough when lives are crossing beneath. Today's ships are stronger. Aircraft are smarter. Forecasting models are better. But the traffic is heavier. More cargo, more flights, more pressure to stay on schedule. Climate change is altering the North Atlantic. Temperature contrasts are increasing. Storm tracks are shifting. Systems are intensifying faster. Captains report wave behavior unlike anything recorded decades ago. Pilots encounter turbulence zones previously rare. The margin for error is shrinking. The ocean is adapting faster than technology. The North Atlantic crossing remains essential. It feeds economies, connects continents. It moves the world, but it has not been conquered. It waits for mistakes, for miscalculations, for overconfidence. Even satellites, our highest vantage point, cannot fully tame it, because this ocean is not just water. It is motion, energy, conflict, and it reminds us every generation that nature does not negotiate. It only allows passage.